Hi everyone, this talk is a quick teaser for our paper about a very practical problem, recognizing real and multicultural dishes using today's vision language models. The headline is simple. When the labels are culture specific, VOMs often guess or generalize, and we compare two fixes, whether using VOMs to generate name with RAG or using VOMs to re-rank a short list of no labels. So why culture specific food breaks VOMs? In general, food recognition is deceptively hard. Visually, the same dish can look very different depending on who cooked it. Linguistically, many dishes having multiple names or spellings across cultures. And in practice, there's domainship, where curated web photos can be very different from images captured by your phone. In our paper, we show that RAG can output plausible name, but often very generic label like stuffed pasta, or it can propose a name that culturally off. So, our paper asks a clean question: what is the best role for a VOM in food recognition? Our option A is using RAG. We provide a dish name classifier, a recipe retriever, then we refuse the result. And we use this kind of like result from either classifier, retriever, or the fusion result to ask the VOM to generate a dish name. This is somehow powerful, but open-ended naming is very fragile when classification, retrieval, and fusion results are imperfect. And our option B is search re-ranking. We use the same classifier, the same retriever, together with the same fusion approaches. Then we let the VOM to do what it's good at, which is choosing the best candidate among a candidate list by just reading the visual evidence. Method-wise, the setup is intentionally modular so that we can compare between RAG and re-ranking. The key design choice here is keeping the final decision inside the no taxonomy while still leveraging VOM robustness under domainship. So here are the results on our hardest testing, where we use the HPV testset containing resident uploaded photos and consider as our domain testset. You can see that a strong classifier is around 82.3% in top 5 accuracy. Fusion can help boosting the result. The best overall performance comes from Fusion plus VOM re-ranking, reaching about 87.6 in top 5 accuracy. RAG can somehow approach that number using a stronger VOM, but it's less consistent because the model is allowed to invent new names. And finally, there's a note for deployment where list-wise re-ranking about like 14 times faster in speed comparing to point-wise, making it more deployment friendly. So to wrap up, for culture-aware food name recognition, VOMs shine as re-rankers where they can use their robustness to reorder a short list. Our paper digs into culture-wise performance difference and concrete failure cases, and it lays out a modular pipeline where you can deploy and upgrade easily. If you're interested in this practical VOM use beyond demos, I would encourage you to read our paper. Thank you.